That's an activation function, as I uh, I told in the last session. Activation function to check whether the particular node or neuron is working or not. Work ஆகல அப்படின்றப்ப அந்த இடத்துல you will not get any kind of output. So it may go to negative also. So what we have to do, we can apply this normalization to make it as a positive value and make that particular node to work or identify the problems, solve it. Normalization apply பண்ணி we are getting the positive value as the output. So it is simple. To make a positive value in the output, we are using a norm. It's a function. It's a function. So it's important in machine learning, and also it is used to, as I told you, evaluate the error. Or node work agala, you are getting the different value. So you can easily find out. Which node is not working, why we are getting error in this particular value. So that time what you can do, apply the function and you can able to solve it. Okay, so all these theories are just to make you to understand. Just is a function, you can call the function in order to change the vector value into the positive value. This is just the definition of norms. Okay, and also it is mainly used to mitigate the error and calculate. The first point, used to calculate error between the output of a neural network. Always you have to imagine the neural network whenever we discuss another topic. Deep learning when we discuss, imagine the neural network structure: input layer, hidden layer, output layer. Okay, hidden layer can be n number of 1, hidden layer 1, 2, 3, 4, எவ்வளோ பெருசு வேணாலும் இருக்கலாம். Or this is the structure, you have to remember the structure. So this mainly this norms used to calculate error between output of neural network. Okay, output of the neural network. Yes, ஏதாவது output error இருந்துச்சு அப்படின்னா you can apply the function. Always what is expected, actual value. Okay, whatever the input we are getting, we need to get an actual value, right? Sometimes if we get error, this norm can apply and solve the error. Can be defining the regularization term. So these are all okay, fine. And it is a function that maps a vector to positive value. It means it will be always a positive value. Okay, so it's a function which always makes the vector value to be a positive value. The norms. Now, maybe they can ask in 2 marks, what is norms in deep learning? A function that maps vector value into the positive value and used to find out the error in the neural network output of the neural network. So this is only 2 points. There are some properties. No, properties of norms. The vector norm should be a non-negative value. Always norms should be a non-negative. You know, it's positive means what? Non-negative value. Like length, you can easily calculate. Always the length should not be a negative value, will be a positive value, right? So one example, you can calculate the length of anything. Okay, norms are 0. It can be 0 if and only if vector itself is a 0 vector. Okay, it should be a positive value, but it can be 0. Vector value is 0 it will accept it. Okay, it follows triangular inequality. So what is the triangular inequality? Sum of the norm of sum of vectors is less than or equal to sum of the norms of vector. So it follows the triangular inequality. The vector is stretched, the norm is multiplied by the stretching factor. So this is an example how we can stretch the matrix value and how will you multiply it. We will see in the next coming slides. Okay, so the same here also, you can call the norm as vector norms. Okay, we can call as a vector norm. It's a non-negative norm. It's a non-negative number which describes the vector in space. It describes the vector in space. Sometimes it is referred as magnitude of norm. Okay, so when you calculate the magnitude of the norm, we say it is a vector norm. Okay, so here to represent these vector norm, we have some of the notations away. We have some notation. That notation you have to see, mainly used for calculating the vector norm. Okay, so what is those notation? There are two types of norms. So norm is same as vector norm. Okay, we'll be calculating the magnitude of this vector norm. So it is called the name vector norm. So it is of two types. See, vector L1 norm. First type is vector L1 norm and the second type is vector L2 norm. Okay, there are two types, but these two types is using two different methods. So classification of norms classified into broadly into two types. Okay, L1 norm, vector L1 norm and vector L2 norm. First, we will discuss how this L1 norm is working. Okay, so this is mainly used L. L is meant for length, that you can remember. L1 and L2. So mainly this function is used for calculating the length. So the length cannot be a negative. It can be only the non-zero or positive, non-negative or positive values. Okay. So what is the notation of L1 is, see, modulo, you can say double modulus of 1 because it is a L1 norm. So the vector is calculated as, say, double module V. So